Hello, everyone. Welcome to our second monthly meetup. It's been a few months since we have had this user group. We had our last meetup in March, and here we have in April. We have a lot of exciting things lined up for this session. We have two presentations where we'll take some case studies, and then we'll have four plugin authors who are with us who have published some plugins with QGIS, and we'll see the demos of those. We'll start with a short overview of where we are as a user group and some of the initiatives. We'll see the status, and then we'll dive right into the presentations. I'll start with the updates on where we are as a user group. The community has been growing steadily. LinkedIn is our largest community now. We have 800 plus members there. We have the Telegram group where a lot of people are there. And then we have our mailing list, which is the main mailing list for coordination for volunteering and people to contribute content. We have a new YouTube channel. And if you haven't subscribed, please subscribe. This is where we'll post all the recordings. Even this particular meeting's recording will be on YouTube later on. If you want to join any of the meeting working groups, please email this group. We have several new people who are joining this meeting. So if you're new and you want to volunteer for something for the user group, you can email this user group and we'll connect you with the resources to get you started. We also have a platform for content. We have lots of case studies and tutorials that are already published. Several of you have published those. We got hooked into our QGIS analytics. So we have some stats on how the content is being viewed. You can see the tutorials that we have are quite popular. People have been looking at those. So again, we have a lot of experts who know how to use QGIS. Maybe you used QGIS and related technologies to solve a problem and you would like to share. We have a platform that you can actually contribute content to that. And we have an amazing content team who's providing with great feedback, and I think they help you also improve your content. So if you are interested in writing some content or writing a tutorial, please email the user group list here, and then you'll be able to share the content on the website. Since last month, we have a new member directory on the website. Again, this is an informal community. So again, everybody is welcome. We have so many people who kind of are part of the group, but we wanted to actually know some more information about who people are. And it'll be nice for each of us to connect with each other. For example, like I want to know who are the QGIS users in Delhi, or if I'm going to some other place and want to connect to other community there. So it'd be nice to kind of have your information there. So if you are part of any of our groups and want to list yourself, here's a QR code. You can also go to the website and submit this. And it'll be nice to kind of have it listed there. We'll shortly update the website to add your LinkedIn profiles as well. So again, it's a good kind of simple way for people to connect and reach out to each other. Aravinth, you can give the updates on translations.
Yeah. So from the last month to this month, we have not had much progress on most of the languages. We are a bit static. Yeah. So as far as one language, we have almost completed with 97% translation. But rest of the major languages, we are still on about 85 to almost 95% translation pending. But over the course of this month, a lot of people have shown their interest in translation, especially we got major people for Hindi and as well as Bengali and then Gujarati. I also got in touch with some of my juniors from the past university and worked on the current students which I'm taking. Most of them from, like probably Hindi and then Bengali and then as well as Malayalam background. So for the most of the languages between serial number 1 to serial number 6, I've already at least got 2 to 3 people who are willing to contribute their work. So I will probably this coming next week, I'll give them an orientation on the transfix, and probably we'll start with this week. So hopefully in the upcoming month, this pending translation would definitely get reduced at least by 2 to 3%, because there are about 1,500 for every languages. There are about 1,500 strings to be translated, and words are about, I would say, in approximately 8,300 or 400 words. So once we have people regularly work on it, then probably once we pick up the pace, and I think that this is definitely doable, where we can achieve at least 50% of the work completion. I would say by in the next 5 to 6 months maximum. So we'll definitely work on this. Uh, that's it from the QField, translation update. So the second slide is for the status of QField words, and the first one is for the QField strings. So yes, but for the other languages, I've also reached out to some of my contacts. I'm still waiting for their input. We were thinking that how we can, apart from the QGIS community, that maybe reaching out to maybe colleges and universities that specifically have geospatial as a subject that they teach. So it will be easy for us to, get them into the QGIS community and then have us help. I mean, help us, in terms of outreach and as well as transfix translation work. So we are working on it, and we had a couple of ideas which we put it in the events group as well as and then the normal QGIS group. So once it is finalized in the next 1 or 2 weeks, I would say then we can go ahead with it. I'm thinking that at least by the end of December, that we try to achieve at least 70% translation completion, at least for the major languages, and then try to focus on the remaining languages as much as possible, that I would say. So that's it from my side.
Yeah, thanks, Aravind. So there are a couple of people who are interested in contributing. I've shared the link to the mailing list thread where
Yes.
there is an update on there. We also had a live session, which is also available on YouTube. So you can watch that on the translation process. And then you can join that email thread and just reply and saying, I want to join. We'll add you to the relevant team on Transifex and we can start working on it. And this is largely a volunteer effort that we're all trying to contribute. The QField team said if there are more than 75% strings translated, then it'll be packaged with the app. So if you have a language which is more than 75% translated, all the users of QField will be able to switch their interface to that language. So let's try and aim to have that available soon for our Indian users. Next we have Tara. So Tara, you can share your screen and share your presentation.
Okay, thank you. 1 second. Okay, thank you very much. Very good evening to all of you. And I'm just going to jump right in. And title of my talk is How We Delineated Tiger Corridors in Central India. So for some background, here is a map showing the network of protected areas in India. Roughly 5% of India's geographic area comes under some form of legal protection. And the NTCA, the National Tiger Conservation Authority, which is the main body for tiger conservation in India, says that a genetically viable population of tigers needs at least like 800 square kilometers of inviolate habitat. But out of more than 600 protected areas on this map, only 7 of them have areas of higher than 800 square kilometers. And there are plenty of studies and reports that show that the tiger, which is highly territorial, is capable of long-range movement to find mates and suitable habitat. And even the Ministry of MOEF, Ministry of Forest Climate Change, has said that around 30% of India's tigers roam outside protected reserves, and that there is a need to strengthen tiger conservation beyond protected areas. So people who are working in this field of wildlife conservation have long known that protected areas by themselves are not enough for conservation. And this is not just true for the tiger as well, but for a variety of species, not just mammals, but even birds and insects as well. So in light of all this, some organizations which are working on conservation in India came together to form the Coalition for Wildlife Corridors. So I worked with the Coalition for Wildlife Corridors as a consultant. One of the mandates we worked on was to develop, share, and standardize approaches to corridor planning. So basically, this translates to two things: agree upon best practices to identify wildlife corridors in India, and then use the method to identify areas of high probability of tiger movement in CIL, which is the Central Indian Landscape. This is our study area. I'll talk about this a little bit. Around 14 protected areas are there here. And this is quite a large landscape. Most of the protected areas are in a matrix of shrub and cropland with some closed forests and some open forests as well. These blobs of built up areas are cities, like this is Nagpur is around here, Jabalpur is around here, and administratively also it's a very complex region. Like most of these are in Madhya Pradesh, and in fact, Maharashtra cuts through the Pench Tiger Reserve. And this part of the landscape is in Chhattisgarh. Kanha is in Madhya Pradesh, but this small sanctuary right here is Boramdev Wildlife Sanctuary, and that's in Chhattisgarh. So a pretty large and complicated landscape. So in the approach that we discussed, the first step is to identify the nodes in the landscape. And these are the 14 protected areas in CIL, which we talked about. The next step was to generate a resistance surface. So a resistance surface is nothing but a raster layer where each pixel has a value representing how difficult it is for a tiger to move through that pixel. So conceptually, how we do this is the process we use to generate a resistance surface. We have several variables of interest. These could be rasters, these could be polygons or linear networks. And we take several inputs and then we rasterize them and reclassify them into standard values of like areas permeable to the. And then we do this something called a weighted overlay, which several of you will be familiar with. This is nothing but a raster calculator operation in QGIS where you multiply each raster with a weight and sum it all up. And this gives us a final resistance layer. So for in the previous slide, the main question is actually what are the input variables that we're going to use, and what is the weights that we assign to each of these. This is called the parameterization problem for the resistance surface. Now, many studies approach this parameterization differently, and as the group, we did talk about what are the best practices to do for parameterization, especially when we are considering a large landscape. Data will not be equally available throughout the landscape. So the main thing is we classified the kind of available data into different tiers. And in the landscape, we decided that the best practice was to use any available data and prioritize the higher tiers. So for our specific Central India, we had access to tier 1 genetic data, and the details of the parameterization are in Thatte et al. 2018, and the parameterization process was carried out in R and QGIS. And roughly this is what our resistance surface looked like for the Central Indian landscape. Now that we have the resistance surface, the next step is connectivity modeling. So for connectivity modeling, we had two approaches. We examined two approaches. The first was cumulative cost to movement, or CCM. So conceptually, what that does is when we have a resistance surface with several protected areas, you can think of the cumulative cost to movement as when you move farther away from protected area, the cumulative cost increases. So each protected area in turn, we do this for all the protected areas and then we put them together. So, I mean, I'm glossing over a lot of details here, but bare bones, this is what happens. Now, the second approach was actually circuit theory. So, when we take the resistance surface in 12th class, whoever has done any sort of competitive exam prep here knows that we have Kirchhoff's laws, which allow us to calculate the current flowing through any branch of a circuit. So the resistance area is actually, in circuit theory approach, the resistance surface is treated as a giant circuit. Each PDS in turn takes turn being the earth, and then you have multiple circuits generated this way. So using these formulas that we have for engineering, we can calculate the current in each branch of the circuit. And the current here is actually analogous to probability of tiger movement. High current flow are areas of high probability of tiger movement. Once we get all these together, then we mosaic the results of all of them and we get the resultant connectivity surface. So these were the conceptual overviews, and the tools we used for these methods were actually several tools from the linkage mapper toolbox in ArcGIS. We did not find QGIS equivalents for this. And for circuit theory, we used a program called CircuitScape, and the input for CircuitScape required several rasters to be processed a certain way. So I used QGIS to align and resample input rasters, which could be fed into CircuitScape. So these are the final outputs of the analysis. As we can see, this is the output of CCM and this is the raw output of circuit theory. And now from these rasters, we needed to get them to contiguous polygon files. So that was the next step, to synthesize these outputs and develop actual corridors from this. So the idea was that there were several, actually this was a very iterative process that took a very, very long time. I'm simplifying it here. The idea is we have the output rasters and we need to end up with contiguous polygons between the protected areas. So that involved a lot of back and forth, and it involved several types of operations. So here I've given a bunch of the operations I used in QGIS, converting between rasters, polygons, reclassifying, threshold detections, etc., etc. Most of the tools I used here were native to QGIS and the processing toolbox, and we needed a few Python scripts that I had help from some collaborators, and I also explored the LECOS and minimum spanning MSP plugin. So for in QGIS to help with this work. So yeah. So then here are the outputs of the two approaches. The output of the CCM method is shown in blue and the output of the circuit theory is shown in red. Here I've overlaid the CCM on top and circuit theory below. Right away we can see that some areas like this is Kanha Pench corridor. We have a lot of on-ground information that shows that this area is used, and that surprisingly was not picked up with the CCM output. And similarly, in these areas, Bandhavgarh and Sanjay Dubri, a bunch of areas here were not picked up by the CCM. And correspondingly, in circuit theory approach, it had a lot of coverage, but it completely ignored this entire branching linkage, which is pretty important because it connects several areas which have good breeding population of tigers. And also, circuit theory did not have any sort of linkage between Panna and Bandhavgarh, but there was a newspaper report of a tiger going all the way in this landscape as well. So both of these approaches, even done on the same resistance surface, gave us useful information. And we combined the outputs to create the synthesized output. Now, the next step was to compare with other studies in the landscape. And for that, the first one we checked out was the Pan-India least cost path for tiger movement provided by the NTCA. And this was done on their resistance surface. And this is just the LCP is just the least cost path algorithm. So basically, if a tiger had access to Google Maps, this is how it would navigate the landscape. And NTCA, one thing is NTCA does it only for tiger reserves like Bandhavgarh, Kanha, Pench, Satpura, Ratapani, Navaradehi. These two small protected areas, Bor, Umred, Khairnar, are not actually included in the NTCA. And the second study, which was of importance, was a very interesting study known as Schoen et al. 2022. And this was consensus connectivity areas. So what they did in this study was they looked at 5 different studies in this landscape, looked at the resistance surfaces which they had parameterized, and it looked at the areas which had more than 80% convergence among all the 5 studies. So that was pretty robust in the sense these areas which you are seeing in yellow are the areas that 5 different studies agree are important for connectivity. And when we compared our output, which of course I did using QGIS, over 98% overlap was there for the NTCA coverage, just one small bit of this Bandhavgarh and Sanjay Ghasidas, and one tiny branch this side of Melghat was not picked up. But for the consensus connectivity areas, our outputs had around 84% overlap. On closer examination using QGIS, we found that most of the areas which were not overlapping were actually very tiny, isolated fragments, disjointed fragments. And but the interesting part was around like Bor, which is a very small protected area, and Nagpur is close by, but different studies agree that these areas around Bor are important for connectivity. So because of this, we took a call to add some areas around Bor to our corridors, which we had previously excluded. So, and then that comes to giving us the final output of this exercise. So here are the polygons. We are calling the more linear pathways between protected areas as corridors and the long branching as linkages. But realistically, it's nothing but a naming convention that we are using. And of course, all the maps and all the work in this, like the outputs and publications, whatever maps we used during the study was done in QGIS. Now, even though we have these as polygons, these are absolutely, we cannot definitively say that this is a corridor area and outside it is not a corridor area. This is all just a probability at the end of the day. And what these are going to be used for are just a first cut. Now, the next step is actually to create local working groups in each of these areas, zoom into each of these areas, and take an approach which is multi-stakeholder corridor conservation planning. We go in with these boundaries, have meetings with local field workers, with people who live in the region, with policy makers and especially forest department people, take in their input, refine the approach, and hopefully we want to expand these areas. This corridors was modeled specifically for the tiger, but ultimately what we need are corridors which are useful for other species as well. So this output, what you see here, is pretty much nothing but a first draft and is very much in the refining stage using this approach. So yeah, that's it. We have some photos. I am Tara. Anyone who wants to reach out and talk more about this, best is to email me, and I'm also on LinkedIn and QGIS India Telegram group. Thank you.
Thanks, Tara. Thanks for sharing. If folks have any questions, please let us know. Madhu has a comment. Nice work, Tara. Would be useful to incorporate uncertainty in your modeling?
Oh, yes, absolutely. I mean, these, in fact, what we are doing, even when going with the local groups, is to not use these as definitive, but create like a 5x5 square kilometer and snap it over. And when we are talking to local people, we overlay with the administrative districts and just say that this district is important. So for the forest department, municipality, all of that, that's how they release funds. They need to know the actual boundary doesn't mean the districts are what are important. So absolutely. And uncertainty, we did talk about it, but the problem is just the disparity of information and the quality of evidence across such a large landscape. So it was hard to come to a consensus on how exactly we incorporate uncertainty. But you're absolutely right. Ideally, it would be great if we could have some as well. Yeah.
There's one more question from Guru Datta. The concept of resistance layers was insightful. What was the resolution, and was it focused exclusively for Tiger movement only?
Yeah, absolutely. So the resolution was the LULC resolution to 1 square kilometer, and then it was focused. Each resistance surface is actually specific to the animal that we are focusing on. So, like for example, if we are looking at, if we consider the tiger, if we want to have corridors for the tiger, then railway lines or would be a detriment. But if we are say modeling for the Indian vulture, which is a bird, it can fly over the railway lines. Or and is the dispersal distance. How far can an animal travel? So these are the two considerations which we take into account when making the resistance surface. And it has to be species specific for this particular region. Another thing is tigers are solitary. What about the animals that live in groups? Like for elephants, it's even more complicated because the females form groups, but the males can roam solitary. Sometimes they form groups. So there is a lot of nuance that goes into this, which is why we actually kind of need to formalize the approach and decide the target species we are focusing on. The main point is hopefully tiger is an umbrella species. So the area that tiger, large ranging umbrella species, so that the areas which tiger uses are also used by cheetal, sambar, several of the herbivores which have shorter dispersal distances, say. But yeah, I hope that answers your question.
Cool. Thanks. If we have more questions, please put them in the chat. We'll also do Q&A at the end, but let's move on to the next speaker. We have Dr. Smruti Rekha Sahoo with us. Smruti, you can share your screen and present your work.
Yeah. So good evening, everyone present here, and I'll be talking on spectral remote sensing in direction of mineral targeting. As we are talking related to the Earth Day celebration, so I thought I'll put some eco-friendly technique and how we can use remote sensing and GIS to validate it for environment conservation. And I am Dr. Smruti Rekha Sahoo, an assistant professor in the Department of Geology at Fakirman University, Balesar, Odisha. So, one second. So these are my outlines. I'll talk on objective, introduction, study area methodology, result discussion. Then I'll summarize the points. And introducing the topic, I will discuss about the spectral remote sensing. I'll talk here about different types of satellite images from where I have extracted the iron ore deposit specifically. I'll show that. And finally, I'll try to show the iron ores from my study area that I have taken Keonjhar district of Odisha. How it has been highlighted in different types of imageries, and uh, I'll summarize like how eco-friendly the technique is. So as I told, my objective is to meet the global environmental challenges to target the minerals in eco-friendly way. So these are different methodologies I have used because I have informed earlier that I am using three different types of satellites I'll talk about. One is Landsat, another one is Aster, and the final one is Sentinel. So using these kind of satellite images, I have processed it using different techniques, using remote sensing processing, image processing softwares, and the maps, final maps for highlighting the iron ores present in the study area is being depicted using the GIS software, or it is the QGIS. So this is the study area. In India, the Keonjhar is present in northern part of the Odisha, and here the Google Earth image is showing the study area, and this is the geological map of the area, and it is a horseshoe synclinarium presenting the iron ore geology. And coming to the results, This is the result of Landsat image, where the first image is showing the flash corrected image of iron ore of Keonjhar district, and the second one is the band ratio image, where the bands are taken like band 4 and 2, which if I zoom this part of the district, here the red colors are highlighting the presence of iron ores, and these are been mapped, or the layout has been prepared using the QGIS. Here the for the aster image also the same. I have tried to find the iron ore deposits, and these are the images showing the dark object subtract method, and this is the first image showing the dark object subtract method, and the areas as I shown in the geological part is the synclinorium is highlighted in subtraction method, and the second is the band math, where the areas with the iron patches has been highlighted with white color, and finally the band ratio method for the image third image, which is the formula is band 5 by band 3 plus band 1 by band 2, and here also the iron ores has been highlighted with some bright reflectances. And this is the image which is prepared for the final output of the iron ore deposits or iron oxides present over the study area. And here the pink color or the magenta color is showing the iron ore present in the area. You can better visualize in the larger area, and it is the zoom part of this particular area I am working on in the Keonjhar district. That is Joda area. And here also the FCC combination of a 468 band showing the iron oxide in the dark color patches. This is the final output image of the aster data, which is the classified image. And here the iron ore is depicted in the red color, the maximum iron ores present shown in the red patches, and the yellowish part you can see is the ferruginous shell present in that area. And here I am showing these things have been prepared using the QGIS software, and earlier to that, I have processed it using image processing software. And then I come to the Sentinel-2 image, where the Sentinel-2 image has been processed using the band ratio mapping technique, where the first image has been used the band 11 and band 8 ratio, which highlights the ferrous iron oxide distribution in white patches. The second image is showing the band ratio with the band 4 and band 3 bands, which shows the ferric iron oxide in blue patches. You can see these blue patches all over the area. And this area is part of Keonjhar. This is Zoda and this is Birdbill. So in this zone, the blue patches have been highlighted to identify the iron ore deposits in that particular area. And the final third map is the band ratio map of band 11 and band 12, which shows the hydrothermal alteration zones. And the iron oxide is highlighted in the dark patches, as you can see over this area. So all the different techniques has been applied to these different types of satellites, and using different bands to highlight the iron ore in the study area, like for Keonjhar district. So with this, I'd like to summarize that the Landsat, Aster, and Sentinel-2 data is of high precision mapping for iron ore deposits, particularly in the Keonjhar, Odisha, India, and also it may be used for other parts of the globe. And the band receiving technique are highly effective for identification of iron ore bearing groups. And as I told, it is we are talking about Earth Day, and these works has not take much time or many cost or more effort to demarcate the iron ores, and it is the trending method we can apply for compared to the conventional field-based geological surveys. So spectral remote sensing, particularly the band receiving method, may be used better identification of the mineral targeting, which is very eco-friendly, and maybe we can say it is alternative to the traditional exploration methods of minerals. So yes, it is an eco-friendly technique which doesn't need any physical contact, and it covers wider area to identify your target, and also it is cost effective. It may not need much field work or many manpower, by which our travel and equipments transportation and other transportational activities also decreases, which lowers the carbon footprints, and to save our earth and conserve our environment. So thank you. This is all about my presentation. Thank you.
Thanks, Smruti, for sharing your work. Are there any questions? If there are questions, please feed them in the chat. We'll address them at the end of the meeting. We have now feature presentations from our plugin authors. We'll move to our next speaker, Vaibhav Nagare. If you can share your screen and demo your plugin.
I'll keep it brief. Hello, everyone. I'm Vaibhav Nagare. I'm from Pune. I did my bachelor's in geography and currently pursuing MSc Geoinformatics in Bharatiya Vidyapith Institute of Environment Education and Research, Pune. The plugin that I have built is military symbology plugin basically. So this plugin lets you place NATO standard military symbols on a map with a single click. It's already approved and it's live on QGIS plugin repository. Anyone can install it and use it. So earlier, there was no open source like the symbols were not available, the military symbol. The particular NATO APP 16 military symbol that was not available. So users earlier had to use paid tools, or they have to like draw symbols manually. So this plugin fills that gap completely. So this is like in the initial phase. I just submitted the first version. It has only 14 symbols in 4 categories: friendly, hostile, special, and neutral. So all these are point symbols only. So you can label each symbol with a unique name, and you can export everything to KML or GeoJSON when done. So let me just demonstrate it for you. So if you install the plugin, it will visible somewhere here. So these are the symbols. The dog will be up here. So there are only 14 symbols. If we take the current scenario of the war, we can just simply, let's say, a friendly, if we take the US Marines, for example, so we can place it like you can name the unit as a company, platoon, or anyone from the defense. So if you take the company and we can just simply place the symbol and it will be up here directly. So yeah, and similarly, if you take the hostile infantry, we can place it here maybe. So maybe we can call it IRGC. Like company only if you take, and we can simply place it. And so this one, these are friendly symbols, these are hostile symbols. one neutral symbol is there, and some of the special symbols. So maybe checkpoint, so we can mark rate of homos as a checkpoint, and we can see we can like simply place the symbols directly. And if you want to export it, we can directly click here, and directly we can export it into KML GeoJSON shapefile in any format we want, and it will directly get saved. So yeah, that's it, I guess. So please try it and let me know. If you have any question, I'm here to discuss. And if anyone wants to contribute to this plugin, the GitHub link is there. I have included in the slides. Yeah. Thank you.
Thanks, Vaibhav. Pretty cool work. We'll also put all the links, GitHub links and plugin links in the video description. So if you're watching this on YouTube, you should see in the video description. Next, Gaurav, you can share a screen and demo your plugin.
Hi everyone, my name is Gaurav. I'm from InQGIS. I'm working in the coastal vulnerability and multi-hazard assessment. So this plugin I have made for identify the buildings which require more time to evacuate and during such a flood or hazard situations, and it will identify the which shelter is near to which buildings and compute the evacuation time along and evacuation routes. So I will quickly demonstrate. So for this, you required three major inputs, building layers. This building layer I have considered for Nagapattinam district, which was the worst hit during 2004 tsunami. And this flood inundation I have generated from hydrodynamic model. And these are the evacuation shelters. Some are within the inundation zone, some are out of inundation zone, and some are very far from the buildings which are at risk. So out of this, the plugin will identify which evacuation shelters are near to the buildings which are at risk. So to run the plugin, you have to go to plugins, building level short test evacuation time. It requires this building layer. You can drop down if your layer is already added. Otherwise, you can use this browser button. So you select building in polygon, then evacuation shelters in point file, then inundation layer. And if you have digital elevation model, then that is optional actually. So if you add digital elevation model, so it will add slope characteristics in evacuation route, along evacuation route. It will model the slope characteristics and which will be like more realistic. And this is the useful for identifying the buildings which are taking more time to evacuate. So local government or disaster management can plan the evacuation shelters accordingly. And it will give you each building wise evacuation time and evacuation shelter where that particular building is associated to which evacuation shelter. So output will look like this. We'll just turn off this layers. So it will also give you the evacuation routes along the routes. I am accessing the OpenStreetMap road network data for this. So it is taking the routes and it will guide you where each building have to go to which evacuation shelter. And it will classify the building based on evacuation time. Like these red color buildings will take more time to evacuate. And these legends, I have added the evacuation times also, like for short and for very long. And if you open the attribute table of buildings, you will get ID assigned, like per building, it is assigned ID. These IDs are evacuation shelters ID and its particular time in minutes. And these are the class values. So if you run this for the larger area, you will identify this is for Nagarpatnam district. You will identify this zone is containing more buildings which require more evacuation time. So if you see, because this is the area formed due to river delta, made this area as isolated island, so which are depend on only 2 bridges, so which also act as a critical infrastructure during such events. So these people, if any evacuation need to be done, then they have to rely on these 2 bridges. So local government or disaster management can plan different type of evacuation, like vertical evacuation or different mode of evacuation for such areas. So this tool will be useful for identifying such structures, such buildings, such areas, which takes more time. Which this is also part of the tsunami ready recognition program, which have total 12 indicators, mainly assessment, preparedness, and response. So within this, there are this tool is aligning with indicator 1, 2, 3, and 4, which is tsunami hazard zones mapping, the number of people at risk, infrastructure, resources identification, and evacuation maps, which are also the component of early warning system. So thank you.
Thanks, Gaurav. Great work, and thanks for sharing with us. We have the next speaker, Bhuvanamitra. You can share a screen and present your work.
Hello everyone, good evening. My name is Bhuvanamitra. So recently I have built a plugin called GeoBearing-Distance plugin, where we can create lines and polygon features using true bearings and ellipsoidal distances. Currently, in our QGIS tool, when we use QGIS advanced digitizing tool, we can only create features using azimuth and distances. Whereas bearing, we can only use it for measurement. This I found it as a drawback, as a limitation, and I have built this plugin wherein you can create lines and polygons with reference to true north and measure clockwise between 0 to 360, with all values being positive. This plugin is mainly used in aviation-related applications, surveying and navigation. I'll just show you a demo of how this works. Is my QGIS screen visible to all?
Yes.
Yeah. Right. Right now, the plugin has already been published on QGIS plugins repository. You can take a look into it. I'll show you how to create a line feature using this. Generally, when you go for toggling, editing, and add line feature, the advanced digitizing panel comes up over here. Okay, wherein we can create features using distance and azimuths, where azimuths are with reference to east to west in positive direction, and east to west on the anti-clockwise direction, it is negative in values. Now, in the same panel, the plugin GeoBearing-Distance plugin comes up. The moment you click on this, you get a small panel on your right side where you can enter bearing and distance values to create features. This also is been enabled with snapping feature as well. So let me create a line feature around this stadium that is shown here. Let me draw a sector of it. Say if I want a line at an angle of 30 degrees with reference to north, you can just type 30 and click lock. The line gets fixed to the bearing of 30 degrees with reference to north. And you can either click a point over here to whatever the distance you want, or specify the distance the way how we usually do it. Say 70 meters, and you can lock it. The locking can be done using a tab and a space bar, or you can just click on lock over here. The moment you left click, that is when you complete the feature digitization. Now with reference to that point, again with reference to true north, the angular measurements have been done. You can see the variations that is happening here. If you want to fix with reference to this point, just click, just right click, the feature is digitized. Right now, I don't have any attribute fields added to this. If you have fields added to it, automatically the pop-up will come up for filling the field values, and thereby you can create features, add the attribute information to it. Sorry. Now, if you want to just fix the distances, say 100 meters in distance, so the distance is fixed, and you can set the bearing to whichever the angle you would need. Say 265 degrees with reference to north. Exactly at 265 degrees, you'll get a point. Similarly, if you want to draw another line at say 160 degrees for a distance of 45 meters, you can do that as well. These are just sample testing I'm just showing, and you can end the line as well. So in this way, you can create lines as well as polygons using bearing and distance tool. Suppose if you don't want to use this, if you want to go back in using advanced digitizing tool, just close the tool and you can automatically the panel, advanced digitizing panel will get enabled. This is mainly used in aviation purposes where you need to construct line features and polygon with reference to true bearings and do the analytics on top of it. I would like to thank Ujaval for helping me out in building this plugin, and also our mentor Nitin Atale for mentoring and reviewing this. Thank you.
Thanks, Bhuvanamitra. It's amazing to see all the diversity of plugins that people are building and for kind of niche and specific use cases. We have our last presenter, Aman. You can present your plugin next.
Yes, we are over time. I'll just take 1 minute and finish it. So when I was testing it out, I was looking at the plugin after a few months and I saw it is broken. I just made a release now, you can see, and now it is working fine. So what the plugin does is, this is a brush selection tool. So you normally have selections in QGIS, but what I wanted specifically for one of a project that I was doing is just brush over and then select. So you can just, this is a tool you'll find in the plugins repository, and you can install the latest version. It looks something like this. Once you have it enabled, you can just brush over and then select. This is very, very handy for me in one of the projects, but again, I thought it will be useful for everyone to take a look at. What you can also do is just increase the radius and then brush over. Again, it works on any CRS. I can change on any CRS and then start working on it. So yeah, that is the plugin. This was inspired by one of the plugins that I was just browsing through. It's called Draw by Brush. It lets you draw features by just hovering the brush, but it did not have the feature of selecting, which I wanted. So if you were to again look at some of these features where you want to add using brush, you want to draw features also, take a look at this plugin. So yeah, I think that is the, hope it is helpful. Thanks.
Yeah. Seems very satisfying to go and select it using this.
Yeah.
All right. Thanks for all the presenters. There are some comments and questions in the chat. So if you want to, if anybody has questions, you can just unmute and ask to the presenters now.
I would like to answer the Tara's comment. Actually, there are some assumptions I have done in this while creating the plugin in the study. I have mentioned that in the GitHub portal. She was asking me whether the assumption used to arrive at speed of evacuation. So actually, as per the standard NDMA guidelines and UNESCO Tsunami Ready Recognition Programs guideline, people should walk during such a disaster. So I computed the walking speed and at different terrain. I use walking as an evacuation mode. So that's it.
Any other questions or comments? If anybody else would like to present next month, do get in touch with us via the Telegram group or just email on our mailing list. We're always looking for speakers, and it's a great platform to present your work to other fellow QGIS members. So look forward to hearing from you, and we'll see you all next month. Thank you. Bye.
Thank you all.
Thank you all.
Thanks all.
Yeah.
Thank you.
Thank you.
Thank you.